lesson here in Chapter 8, talking about rectangles, the rhombus, and the squares. A little different setting for us today. If you notice some toys, don't be too long, just at home. We've talked about the parallelogram and lots of different properties that the parallelogram possesses. Things like both pairs of opposite sides being congruent, both pairs of opposite sides being parallel. Other ones as well involving the angles. And we start to stem off of the parallelogram and branch out into more specific quadrilaterals, such as the rectangle, which is nothing more than a quadrilateral that contains 4 right angles, which you should be pretty familiar with. As opposed to the rhombus, which is a quadrilateral where all 4 sides have the exact same measure. They're all congruent. So you might see a picture that looks something like this at some point, where you've got a quadrilateral. We notice that all 4 sides have congruent markings that are the same. We know all 4 sides have the same length. And then finally, the square, which obviously you're probably really familiar with. It's a regular quadrilateral. Remember, regular means that all sides are congruent and that all angles are congruent. And so those are the 3 different types of quadrilaterals that we'll be studying in this section. At this point, we'll start to talk about some of the properties of the rectangle, the rhombus, and the square. And I've got them set up in a little bit of a table format. And so if you want to set up a table where you've got 3 columns, 1 column for the rectangle, a column for the rhombus, and a column for the square, you can take a moment and do that. What we're going to find is that the rectangle, the rhombus, and the square pretty much all possess the same properties as a parallelogram. They're all parallelograms in nature. They just have other specific things that make them slightly different. You'll notice with the rectangle, opposite sides are congruent and parallel, just like a parallelogram. Opposite angles are congruent, just like a parallelogram. Consecutive interior angles are supplementary, just like a parallelogram, as well as the fact that the diagonals bisect each other. The one thing that makes the rectangle different than a parallelogram, again, is the fact that it's got 4 right angles. And also the fact that the 5th property for a rectangle is that the diagonals are congruent. You don't have that with a parallelogram. Mainly because if you take a look at the angles that are crossing those diagonals, they're different. Which is going to cause the diagonals to be different lengths. Now, they do bisect each other, but they are not congruent to each other. In a rectangle, the diagonals are the same length. So the rhombus, again, will possess all the same properties as the parallelogram, except some other ones that make it a little bit different, which makes it a rhombus, the fact that all sides are congruent. The diagonals are perpendicular to each other. They're going to form right angles in that kind of that middle area of the rhombus. The diagonals also bisect the 4 angles of the rhombus. And also, as I said before, the first 4 properties of rectangles also apply here because those properties are the properties of a parallelogram. Now, in terms of a square, the square is like the granddaddy of all quadrilaterals. It kind of encompasses every single quadrilateral that you can think of. The rhombus, the rectangle, the parallelogram, like all combined, that's a square. So all the properties of a parallelogram apply to a square. All the properties of a rectangle apply to a square, as well as all the properties of a rhombus. So you can see in this section where we're talking about 3 different quadrilaterals, properties are a huge, huge portion of the content that you're going to have to remember here. So hopefully this table format will help you out and make it a little bit easier to remember all the different properties for the rectangle, the rhombus, and the square. So I've got a couple examples set up for you here to take a look at. My chalk tray doesn't hold the board so well. Yes, I do have a whiteboard in my house. Don't worry about it. We don't do math every day. So, examples here. Notice I don't have any answers written down. I'll give you a chance here to kind of jot down the 6 different statements that are here. Essentially what we want to do is we want to name the different quadrilaterals that have each of these properties. In 1, we've got all sides congruent. Number 2, we've got all angles congruent. In 3, we've got that the diagonals are congruent. 4, opposite angles are congruent. 5, which quadrilateral is equilateral and equiangular. And finally in 6, the diagonals are perpendicular. So at this point, if you're still working on getting all the statements written down, you can probably pause the video, get them written down, and then you'll see what the answers are in a moment. I'll give you a chance to kind of try to figure them out yourself, start the video back up, and you'll notice how well you did. So, all sides congruent. That would be 2 of our quadrilaterals being the rhombus and the square. All angles congruent. Well, that's 2 other quadrilaterals that we've been looking at here. And that would hopefully be the rectangle and the square. Which quadrilaterals have diagonals that are congruent? I'm so glad you asked. It's going to be the rectangle and the square. You might think it's the rhombus, but the rhombus has diagonals that bisect angles. It has diagonals that are perpendicular to each other. They bisect each other. But the diagonals of a rhombus are not congruent. Opposite angles are congruent. It's a lot of them. Pretty much every single thing. You've got your parallelogram. You've got the rhombus. You've got a rectangle. And you've got the square. Number 5, equilateral and equiangular. That pretty much means it's a regular polygon, which is only one of them. And that would be the square. And which of the quadrilaterals have diagonals that are perpendicular? That's right. It's the rhombus. And of course, it's the square. So notice that pretty much all 6 statements, we had square in every single one of them. Because again, the square is like the grand poobah. He's like the Mac Daddy of quadrilaterals. He encompasses every single property that we've talked about to this point. So he's a pretty important guy. So to finish up our lesson on rectangles, rhombuses, rhombii, and squares, we've got 2 last examples for you that are right here. In the first example, we're taking a look at a rectangle, and we want to find the length of segment DB, this diagonal, in rectangle ABCD. So we've got the diagonals intersecting at point E. We know that segment DE is represented by 5x minus 3. Segment EC is represented by 4x plus 6. Again, I've got the solution covered up. At this point, if you wanted to attempt to pause the video and solve on your own first, by all means, feel free. But here's how the solution is going to play out. While we do know that the diagonals are congruent in a rectangle, we also know that they still bisect each other, which means that segments DE and CE should be equal. So if we take our 2 expressions and set them equal to each other, get our variables to one side by subtracting, add over the 3, we see that x equals 9. So knowing that x equals 9, we can solve for the length of segment DE, which is going to be 5 times 9 minus 3, gives us a length of 42 units. So DB is going to be twice that amount, which means it's going to be 84. Now, you can see right below the solution here, I also solved for the length of AC. I know I didn't ask you for it, but just to show you that the diagonals are in fact congruent, AC is going to be twice the length of segment CE. So if I take 4 times 9, which is 36, and add 6, that's 42. double that up, you notice that segment AC also has a length of 84, which means that those two segments are in fact congruent. And finally, in our last example, example 8, we've got a rhombus FGHJ, and the measure of angle FJH, this angle in the lower left corner, that angle equals 2 times the measure of angle JFG. So what we want to do here is we want to determine two angle measurements and a segment length. We want to figure out the length of segment FJ, which shouldn't be too bad because we know what the length of segment GH is. And we want to figure out the length of segment JGF, this smaller angle right here, as well as the measure of angle FJH, our angle down here in the lower left-hand corner. So again, you want to pause the video and try to work it out on your own. Now would be a good time, because here comes the solution. Easy answer out of the way first. Since GH has a length of 6, FJ is also going to have a length of 6 because the opposite sides are going to be congruent to each other. Now, in terms of our angle measurements, knowing that angle FJH is equal to 2 times the measure of angle JFG, what we can do now is say that angle JFG is X. And so if that angle is X, its opposite angle will also be X, which makes angles FJH and the angle opposite it, which would be angle FGH, 2 times that amount. So each of those would be 2x. So hopefully you can see here we've got x plus 2x plus 2x. So we're adding all 4 angles together, and that should equal the total amount of degrees inside of a quadrilateral, which is 360. So we add up our x's, we get 6x, set equal to 360, divide, we know that x equals 60. So that means that angle FJH is going to be 2 times that amount, because x was what we used for angle JFG. So we know that this angle over here is 60 degrees, which means that this angle has to be 120 degrees, which hopefully should make sense considering that the consecutive angles have to be supplementary. And so this angle is 60, the angle directly next to it has to be 120. Now, in terms of angle JGF, which is this smaller angle right here, obviously the opposite angles are going to be congruent. The one thing about the rhombus is the fact that the diagonals bisect the angles that they intersect, or that they start from. So if this entire angle is 120, that's going to make the measure of angle JGF 60 degrees. So one of the things that may happen here, and you're going to love it because you guys love math, because we have right angles around our intersection point of our diagonals, we're going to have some right triangles built into the rhombii, which means you may see a little bit of trigonometry. Definitely some Pythagorean theorem. So if you missed anything, make sure you stop the tape, go back, check it out, and I'll see you in class real soon.